Today I will explain you when the analytical solution of the model is used and how this influences the speed of the calculations. Let's first define what the closed form analytical solution is. It is when you can write the variable, here the concentration C, as an expression that can be directly calculated. On the opposite, in the ODE system formulation of the model, it is the time derivative of the variable C that is defined. To find the value of the concentration C at each time point, we need to integrate the ODE system numerically using an ODE solver. One usually prefers the analytical solution, but sometimes we have to use the ODE because the analytical solution does not exist. This is the case when we have a nonlinear Michaelis-Menten elimination, for instance. On the contrary, the typical PK models with linear elimination and zero or first order absorption have an analytical solution. The analytical solution is easy to write when there is only one dose, but when several doses are present and the superposition principle applies, then it can be a bit cumbersome to write, as you can see here. Luckily, the analytical solutions of the most common PK models are already implemented in the Monex suite. They can be called via the PK model macro or a set of elementary macros. Now let's check for each situation if the analytical solution is used or not. First, when you use the PK model macro, then the analytical solution is always used, except if you have transit compartments with the KTR and MTT, or a nonlinear elimination with VMKM, simply because the analytical solution does not exist for those cases. It is also the case if one of the input parameters of PK model is not constant. For instance, if you have defined a clearance CL that varies over time. If you use a set of macros, the analytical solution will be used if you have 1 to 3 compartments with only one elimination term. You can have several administrations via different routes, for instance. On the opposite, if you have non-linearities due to transit compartments or Michaelis-Menten eliminations, or more than 3 compartments, or more than one elimination term, as in parent metabolites models, for instance, then the macros will be internally replaced by the corresponding ODE system. It is possible to combine the use of analytical solutions with ODEs by, for instance, having a first part, the PK, defined with macros, and a second part defined using an ODE system. Regarding regressors, the use of the analytical solution is possible if the regressors are constant over time for each individual. Otherwise, the system is not linear anymore and the analytical solution does not exist. When an occasion column is present, the analytical solution is possible when the occasions are separated by washouts. Now comes the interesting point. Which one is faster? If your entire model is encoded by macros and has an analytical solution, then it is always faster to use the analytical solution, because the solution can be directly calculated without having to integrate the ODE system over time. If you have a mixed model with one part encoded with macros and another one with ODEs, then it depends on your model and on your dataset. It is because in that case, the ODE solver needs to calculate the analytical solution at all internal integration time steps, not only at the observation times. Sometimes this takes more time than just integrating the full ODE system, in particular when you have a lot of doses. So it's worth trying both methods to check which one is faster for your case. By default, the analytical solution is used. If you want to enforce the use of the ODE system instead, you can add to the structure model file the following line: use analytical solution equals no. It has to be in the PK or equation block. That's it for today. Have a good one.